My last video I already explained you about the physical property of metals and non-metals. Because our chapter is metal and non-metals, and we are going to discuss about their properties. So we already discussed about the physical properties of metals and non-metals. Now, I have given some hint about the chemical properties of metal reactions with oxygen. So today I am going to explain in detail. I have written to cut short the time. Here, this is Na sodium, K potassium, O oxygen, O2. Then this is sodium oxide, this is potassium oxide. So what happened? Since sodium and potassium, these two metals are very too much reactive metal. So at room temperatures, when they combined with oxygen, that means oxygen is present in air. Then when sodium and potassium at room temperature, that means room temperature means which temperature we are staying at room. This temperature, sodium react with oxygen and produce sodium oxides, and potassium also same. Both are too much reactive, and potassium with oxygens they reacting and produce potassium oxide. These reactions happen only room temperature. Now, in comparison of sodium, potassium, magnesium, zinc are less reactive. That's why when they also react with oxygen, but not at room temperature. So in which situations they react? They react by heating. When magnesium and oxygens we heat these two elements, then we get magnesium oxide. Same thing when zinc and oxygens, when we heat, we get zinc oxide. So these are the reactions. Now, in comparison to magnesium, zinc, iron and coppers are less reactive. That's why in comparison to magnesium and zinc, that's why when we react with combined iron and Fe means iron to oxygen, when we combine iron and oxygen, so we have to heat strongly or prolonged for a long time. For a long time we heat these two elements, iron and oxygens, and we get the iron oxide. And same thing, the copper also less reactive metal, and that's why we have to heat for a long time, and we get copper oxide. Now reactions with non-metals. See, non-metals are carbon. All the non-metals not react with normally with the oxygens normally, but here the carbon react with oxygens when we heat, strong heating. I have written here strong heating. After strong heating, we get the carbon oxide and carbon dioxide, carbon monoxide and carbon dioxide. Because now, perhaps you have seen that when we burn coal with a strong heat, then we get the carbon dioxide gas. Okay. Now, these are the reactions of metals and non-metals with oxygens. Now, coming to the reactions with water, metal and non-metals. Now, as I already told, the sodium, potassium, these are very much reactive metals. So, when they react with water at room temperatures, normally they react with hydrogen, water, and H2 is a water, and they make these two elements, water and sodium together produce sodium hydroxide and hydrogen. H2 is hydrogen. Okay. Sodium hydroxide and hydrogen. Now, these are the metal is now the next the magnesium and water. Magnesium and water, when they react with magnesium, they produce magnesium oxide and hydrogen. Similarly, zinc with water, they produce zinc oxide and hydrogen. In this way, these are the, as per their reactivity, all the metals, they react with the non-metals, with the metals. And whereas the non-metals, they don't have any reactions with the water. Because that means non-metals do not react with the water. Now, so here with the magnesium with boiling water and Sodium, since it is very reactive metals, so at cold water it can react, whereas magnesium react with the boiling water. Magnesium and zinc with the boiling water or steam, they react, and the non-metal do not react with the boiling water also and steam also. This is the difference between the chemical properties of the metal and non-metal. Now, corrosions of metals. Now let me explain the corrosions of metals. What is called the corrosions of metals? Corrosions of metals is nothing but the eating off of metals is called the corrosions of metals. Now, normally you have seen that if you keep iron, copper metals and outside in moist weather, so slowly you will see there is a coating on the metals. On iron you will see brown color coating, and the copper you will see the green color, greenish coating. So what is this? These are nothing but they form the oxide with the moistures, with the oxygens present in the air. With this element, the metal, iron, copper, they make the oxide, and this oxide just slowly eat, or better to say, they just spoil the upper layer of the, suppose this is a metal iron rod, so upper layer, they slowly they eat with this oxide, and that upper layer of the metals just spoil, and this is called eating up or the corrosions of the metal. So that since it destroyed the metals, so we say the eating of the metals is called the corrosion. Okay. Now reactions of metals in dilute acids. Now reactions of metals with dilute acid. What is called the dilute acid and concentrated acid? Two types of, one is concentrated acid. So what is the difference between dilute acid and concentrated acid? The dilute acid means in the water the percentage of acid is very less. Suppose 100 milliliter of milliliter, percentage may be 10% or 5%, like that, as per the requirement. These types of acid is called that 100 milliliter acid, dilute acid means suppose 90% having water and 10% acid. Okay, maybe sulfuric, maybe hydrochloric acid. So this dilute acid is called that where the percentage of acid is very less is called dilute acid, and if the percentage of acid become 50% or more 60%, then this types of with suppose 50% or 60% water and in this and 50-50 acid and water more equal, then this types of acid is called concentrated acid. So concentrated acids we don't require in our reactions. We require only dilute acid for our chemical reactions. So we always work with the dilute acid. Now that's why let's make the conception clear. What is called the dilute acid and what is called the concentrated acid. So now let me explain that metals reacts with the form the hydrogen acid to form salt. Now when the metals react with the acid, sulfuric acid. Three acids are very strong. One is sulfuric, one is hydrochloric, and one is nitric. Three acids are very potent. They are called the strong acid. What? Hydrochloric acid, sulfuric acid, and nitric acid. So when sodium, potassium, as I told, they are very much reactive metals. So when they react with the this acid, they form salt and hydrogen. So let me see that 2Na plus HCl. I am not balancing, I am just showing you NaCl plus H2. Means sodium, this is called salt, and this is hydrogen. Okay, so when the sodium, potassium, same, potassium plus HCl, H2SO4. This is called hydrochloric, this is acid, this is called sulfuric acid. So they produce potassium sulfate, K2SO4 plus hydrogen. Okay. So magnesium, sodium, potassium, in this way they produce the salt. This is called the salt, sulfate salt. This is chloride salt and hydrogen. So what conclusions we have got? That when metals react with dilute acid, they produce salt, respective salt of this metal and hydrogen. Okay, these are also called the displacement reactions also. Why displacement reactions? Because see, sodium is more reactive than hydrogen, and that potassium is more reactive than hydrogen. So when they combine, they just displaced hydrogen from their place and they captured this place and they make salt. And same thing here also, they displaced hydrogen, or better to say remove hydrogen and capture this place and they make their respective salt. This is the reactions with the metals with acid. Now magnesium reacts less violently. These reactions I think more violently because they are very much reactive, but magnesium reacts less violently than the sodium. And why? Because magnesium's zinc, these are less reactive than the sodium, potassium. Okay, so that's why they not react so violently with the acid, sulfuric acid and hydrochloric acid. But they produce hydrogen gas. Magnesium Mg plus HCl equals to MgCl2 plus H2. Okay, so in this way the magnesium chloride, since it is also magnesium is more reactive than hydrogen, so it displaces hydrogen and capture the place and produce the magnesium chloride one salt and remove hydrogen from their respective compound. Same the zinc also more slowly and reacts more slowly and produces hydrogen. Zinc also H2SO4 if you take, then zinc sulfate and plus H2. ZnSO4 plus H2. In this way, so they are also, since zinc also less reactive than the sodium, potassium, so and also less reactive than magnesium, so zinc also react very slowly, and but still they produced their salt and remove hydrogen from the respective compound. Whereas iron reacts also with the iron, you will get more example in your book, that iron also react with the sulfuric acid and hydrochloric acid and they produce their respective salt and hydrogen. Okay, the copper does not react with the dilute hydrochloric sulfuric. Why copper does not react with sulfuric acid and hydrochloric acid? Because copper is very less reactive. In the reactivity series, when I explain you reactivity series, so as copper is far below in the reactivity series order, that's why the copper does not react with the acid, sulfuric acid or nitric acid or hydrochloric acid, because it is very much less reactive. So that's why copper, they has no reactions with the acid. In the other hand, non-metals, they do not react with the dilute acid, that means hydrochloric acid or sulfuric acid or nitric acid. So there is no reactions of non-metals with the acids. So whatever the reactions we are getting with the strong metals. Next video I will explain more about their properties and I will make your conception clear. Thank you.